Hello, in this video I want to present three ways we can define what a parabola is, and I show that these definitions are equivalent to each other. So, first definition that anybody who went to high school probably saw, the parabola can be defined as the curve having equation y equals ax squared plus bx plus c with a, b, and c real numbers. So it's the curve you get when you plot a second degree polynomial. Another way of defining a parabola, which you may have seen, is the parabola is the locus. Basically, it's all the points that are equidistant from a point, which is called the focus, and a straight line, which is called the directrix. So the distance between each point of the parabola and the focus is equal to the distance between the point and the straight line. And the third definition we can use, which is derived a bit from physics, is the fact that the parabola is the curve that will reflect all parallel rays coming from infinity towards a single point called the focus. And what I do is I prove that these are equivalent to each other and basically go from 1 to 2, 2 to 1, 2 to 3, 3 to 2, and 1 to 3 and 3 to 1. I would maybe leave one of these as an exercise if the video gets too long, because it would be basically reversing the steps that we took before. So on the next board, what I start first to do is, this is quite complicated, ax squared plus bx plus c, and I show that we can always rescale our axes to have a much simpler parabola of the form y equals x squared. And we would prove all these equivalences with this equation, with the knowledge that if we really want to get back to a regular, to an arbitrary parabola, we can do it by doing a change of variable rescaling the y and the x axis. Okay. So what we can do first, that is, we take the general equation y equals ax squared plus bx plus c, and we want to transform it in something that looks like y equals x squared. So get rid of all these coefficients. And how are we going to do that? Well, one way of doing it would be to complete the square. As we know, we can take any second degree polynomial, complete the square, and get something that is a perfect square, for example here in x. So it's going to be x plus something or minus something all squared. And this something that's inside the square can be defined as a new variable away, x prime. So what we're going to do first, we're going to divide everything by a. So this is equivalent to y over a equals x squared. Sorry about that. X squared plus b over a x. And then we leave a small space here plus c over a so that I can complete my square. So what I want to do is I want to find something that I can add here, and I will subtract here. So basically I'm just adding the number 0 to get something that here will be a perfect square. If we remember the square of a binomial formula, what we have is we want this to be twice x times the term that will be squared here. So what we have here is, if we add 1/4 b squared over a squared, we will get a perfect square. So it's easy to see that, well, I just will write the next line. It's going to be easier to see. This is x minus 1/2 b over a all squared. So this is the same thing. And of course here I cannot just add it away, because then this is not the same equation. I cannot just add this thing here. I have to subtract it after. So 1/4. So we see that if we take this thing and we square it, we get the x squared. We get the 1/4 b squared over a squared. So it's a plus. And we get here, we multiply these and multiply by 2 to get the middle term, and that's 2 over 2, that's 1, b over ax. So that works. Now what we want is we want something that looks like x squared. We've got it here. This thing we can now call it x prime. Now we want to put everything else on the other side so that we have something equals something squared. So we can just take all these things here and we can just have y over a minus c over a plus 1/4 b squared over a squared. And this thing here, we can call it y prime. So we have something that is simply a translation and a rescaling of the y-axis that gets us a new variable y prime. And this is something that is just, we only need a translation of the x-axis and we get the x prime. So we get an equation of the form y prime equals x prime squared, and all the things I would prove between the equivalence of the definitions I gave before will be based on this, because basically the math is easier, and if you really want to get back to an arbitrary parabola, you can just resubstitute whatever we get doing these calculations with these things, y prime and x prime, and you will get the complete calculation if you really need one, if you really need it. So on the next board, I will start proving these equivalences one after the other. So I've put our three definitions here so that we can remember what they are, 1, 2, and 3. And the first thing I will do, I will prove that if we have a curve of the with the equation y equals x squared, we will get a curve in which the distance between a point called the focus and a line called the directrix is equal for all points of the curve. So d1 equals to d2 for all points. So what we'll do, we will simply look at this curve here. So this is y equals x squared. And we will choose the focus so that it works, and the focus is the point of coordinates 0, 1/4. And the directrix here is the line of equation y equals minus 1/4. So obviously, why do we choose these things? Well, first, because it works. When we do the calculation, we'd see it works. But the first thing we see is that if the distance between the point and every point of the parabola and the focus is equal to this distance between the point and the directrix at x equals 0, we have the y-coordinate of the focus must be equal to the y-coordinate of the line, and the directrix is a line that is parallel to the y-axis, to the x-axis. So what we do, we simply calculate these distances. So we remember we had this thing which we called d1, and we had this thing which we called d2, and we will just calculate d1 and d2 and see that they are equal. So d2 is very easy because it's the distance between the line and the point. How you get it, you just extend a perpendicular to the straight line up to where you have the point, and you measure the length of this line segment. And here it's pretty easy because this line is horizontal, so this thing is vertical, and the distance is simply the difference between the y-coordinates of the line and of the parabola. And here, of course, the y is equal to minus 1/4, and here y is equal to x squared. So d2 will simply be equal to x squared minus 1/4, which is equal to x squared plus 1/4. And now we will calculate the distance between any point on the parabola and the focus, and we just use the standard distance formula, which is the square of the difference in x coordinates plus the square of the difference in y coordinates, and we square it. We take the square root of it. So we have d1 would be equal to the square root of, well, here the x coordinate is x, the x coordinate of the focus is 0, so that's going to be x squared, plus now we have the y coordinate, well, it's y simply, and the y coordinate here is, here the y coordinate is 1/4, so y minus 1/4. Square it, and then we rearrange it with the hope of getting x squared plus 1/4. So what we will do here is we will use the fact that y equals x squared to get something only as a function of x, because here we only have something as a function of x. So if we have any hope of getting to this expression, we need to get rid of the y. So this is equal to the square root of x squared, plus then this would be replaced by x squared, and we develop the square, plus, we'll just start the square root, x to the 4th, plus 1/16, plus x squared over 2, and then we take the square root. Now, x squared plus x squared over 2. Oh, sorry, there's a minus sign, that's why it doesn't work. There's a minus sign. X squared minus x squared over 2 is x squared over 2, so that's equal to x to the 4th minus x squared plus x squared over 2 plus 1/16 square root. And now this is equal to x squared plus 1/4 all squared square root, which is equal to x squared plus 1/4, because this is always a positive number, this is a positive, everything's a positive number, so we don't have to worry too much about the sign of the, is it plus or minus. So this is equal to x squared plus 1/4. Then we have proved that if we have an equation of the form y equals x squared, we will get something that meets this definition of the parabola. And on the next board, I will do the opposite steps. Of course, you could always start like this and get back here, but it's more informative to do it in a different manner. So I will use this as a definition and see that we get y equals x squared. Okay, so I kept the same figure because we will use it to our calculations. So we need to prove that if d1 equals d2 in this setup, then we get y equals x squared without knowing that this is a fact. This is a question. Is that the curve y equals x squared? And the way to do it, of course, is to calculate d1 and d2 and equal them. So d2 is simply 1/4 plus the y coordinate. So that's y plus 1/4 equals to, well, d1. We will calculate it exactly the same way we calculated it on the previous board. It's x squared plus 1/4 minus y squared square root. And if these things are equal, then their squares are equal. This is the way what we're going to use to get to our equations. We square both sides and we get y squared plus y over 2 plus 1/16 equals to x squared plus, and then we square this thing also, 1/16 minus y over 2 and plus y squared. And now we will see that a bunch of things cancel out. The 1/16 will cancel out. The y squared will cancel out. And these two will add up to y equals x squared. So as expected, if we take a curve in which this distance between the point and the focus is equal to the distance between the point and the directrix, we get back to the equation y equals x squared. Okay, so I realized that the video was running a bit long, so I will do it in many parts. So that's the end of part one. And in the next part, we will look at some other relationships between the definitions I've stated in the beginning of the video.